Hi guys, today what we're going to do is we're going to go through some things that you probably are already acquainted with because you've had it um, last year in Algebra 1 and you've probably already had it this year in Geometry. I'm just going to refresh your memory because I want to make sure that you're ready for Algebra 2 next year. So we're just going to go through a few things that are probably going to be a review, something that you're going to start off really early in the year. So today we're going to talk about slope of a line and slope-intercept form, equation of a line, and graphing lines a little bit. If you've already got it, then you probably don't need to go through this video, but in case you forgot anything, just a review of some things you already should have under your belt a little bit. All right, remember the slope of a line is ratio of the vertical change to the horizontal change between any 2 points, and your formula for slope is rise over run, change in y over change in x, right? Y sub 2 minus y sub 1 over x sub 2 minus x sub 1. Very frequently, you will also just see it expressed as slope is equal to the change in y over the change in x. Or sometimes you'll see that expressed, especially when you get a little bit older into calculus, as delta y over delta x, change in y over change in x. That's pretty common as well. So just so you get familiar with seeing some of those symbols. Again, that's red. You would say delta y over delta x, right? That's how you would say that out loud a little bit, okay? All right, so let's just go through a couple, reminding yourself a little bit about slope. So we're asking in the first problem, what's the slope of line B? So let's figure out where line B is. They're kind of labeled, but they're a little bit hard to find. So here's line B right here. So if we want to calculate that slope, we'll look for 2 points. And obviously, if you have a graph, then it's probably a lot easier to just count slope, right? In general, if you have a graph, it's a lot easier to just count slope if you really want to, but we'll do formula as well. So let's take a look at it just by counting. We would, from this point, -1, +2, go down 1, 2, 3, 4, and over to the right, we would go 1, 2, 3, 4, 5. So since we went down 4, we would say that's -4, and then we went to the right 5 in the positive direction, so 5. So our slope is -4 over 5 if we count by the graph. Let's do it with formula just so that we understand how to do that. Remember that slope is y sub 2 minus y sub 1 over x sub 2 minus x sub 1. I think it's a good habit for you to write the formula a lot of times because when you do that, you're just reinforcing that idea. So I'm going to use the first point. I'm going to call that -1, 2. And the second point will be 4, -2. Those are the two ordered pairs I'm going to use. And I'm going to say that this is x1 and y1, and this is x2 and y2. Technically, it doesn't matter which one you choose to be x1 and y1, which one you choose to be x2 and y2, as long as every ordered pair has an x and a y, and you're consistent about which ordered pair you started with. But I'm going based off of how I labeled those. So I used y sub 2, I used -2 as y sub 2, and +2 as y sub 1. So -2 minus 2 over 4, which was x sub 2, minus -1. Remember that that's going to become a positive, right? So then we have -4 over +5, which was the same slope that we got when we just counted it on the graph. Okay? All right. So let's find the slope of line D. Here's line D. Let's figure out where line D is. Line D is over here, up and down. Notice that we're only looking at like 1 point through line D, but line D is a vertical line, right? So if line D is a vertical line, the slope of a vertical line is always what? Vertical line has undefined slope or no slope. Some people say undefined, some people say no slope. I don't have a preference. You'll just have to go according to whatever your teacher or whatever program, if you're working an online program, would prefer. Okay? And I like to think about that almost in a sense of like, if you walk up to a wall and you're trying to walk up a vertical wall, you really can't do that. So it's not possible. It's undefined slope, right? And it could come from trying to divide by, mathematically, that would come from trying to divide by 0. If you actually set that up to solve, then you would say something like, if I'm going to use these two ordered pairs, and this ordered pair happens to be 4, 3, then I might say 3 minus 0 over 4 minus 4, and 3 over 0. We can't divide by 0. There is no number that you can multiply 0 by that would equal 3, so that is definitely undefined, right? That's another, if you'd like to see mathematically why that is. All right, let's move on. Types of slope. You can have a positive slope, negative slope, zero slope, and undefined slope. They each look kind of like this. I would call the positive slope to be an increasing slope, or an increasing line, and decreasing. And if it has zero slope, we would call that a horizontal line. And an undefined slope is a vertical line. Okay. I know that Ms. Mika has a way of showing you kind of how all of those can be related. So she'll kind of make a funny face like this. Positive, negative, undefined slope, zero slope, and I think she does it like this. She'll draw a line like this for positive, and then like this for negative decreasing slope, and then she'll put a U here for that nose for undefined, and a 0 at each end for a horizontal line. I think is something I hadn't seen that before. That's kind of cute, but it's up to you. All right, so let's find the slope of the line through each pair of points and describe it as increasing, decreasing, horizontal, or vertical. All right, let's start off with this one. So slope is equal to y2 minus y sub 1 over x sub 2 minus x sub 1. Remember, that's change in y over change in x. So 7 minus 5 over 8 minus negative 2, that becomes plus 2 over 10. You should always reduce your slope. Since this happens to be a positive number, we're going to say it's increasing. Okay? Increasing. And done. All right, let's take a look at the next one. So again, mathematically, you can go ahead and calculate this. 10 minus negative 6 over 3 minus 3 gives you 16 over 0, which we know is undefined. You don't leave it as 16 over 0. You really do have to say it's an undefined slope, and that would be a vertical line. Right? Okay. It's also a good idea to just look at your ordered pairs first. Save yourself some time. If 2 points have the same x coordinate, then graphically, that would mean that you have a point, let's say here at 310, and a point down here at 3, negative 6. Graphically, if they have the same x coordinate, that ought to tell you that that's a vertical line. So you may just want to say, okay, well, if I know they have the same x coordinate, then it must be a vertical line. Okay. And then if you know it's a vertical line, then you know the slope is undefined. All right? It's just easier than actually working it through. Let's do the next one. So we're going to do slope equals y2 minus y1 over x2 minus x1. Probably should have told you to just pause and do these on your own because you can, and I know you didn't need to see these all worked out. Negative 9 minus negative 4 over 15 minus 12. This becomes plus, so negative 9 plus 4 is negative 5 over 3. It's negative slope. Negative slope would be a decreasing from left to right. So you still need to read your graphs from left to right. So we say it's decreasing because as you look at the graph from left to right, the line is going down. Okay, that's what it would be doing like that. All right. Last one, again, think about the problem number 2 that we just worked. We had the same x coordinate. Well, here we have the same y coordinate. And if you have the same y coordinate, that's your clue that you should have a slope of 0, which is going to be a horizontal line. Of course, you can still work it out if you want to. Negative 7 minus negative 7 over 6 minus 1. It's just not necessary. Like, just try to use your deductive reasoning a little bit and logic it all out. 0 divided by 5 gives you a slope of 0, which means it's a horizontal line. Okay? But you can save yourself the time and trouble of doing the work. All right, let's talk about slope-intercept form and graphing lines a little bit. So we're going to graph lines. Let's talk about some ways to graph a line. If you're given 2 points or 2 ordered pairs, you can plot each point, use a straight edge, draw a line through both points, and you've got your line done. Another way that you could graph a line is if you are given an ordered pair and a slope, then you could potentially plot the point first and then use the slope to rise and run to another point. Another way to graph a line is if you're given the equation in slope-intercept form, which we'll review a little bit in a second. Then some steps that you can follow are to identify the slope, plot the y-intercept on the y-axis. Remember, that should be the ordered pair 0b. From the y-intercept, use the slope to rise and run to another point and plot that. And then if you need more points, you can plot more points. Use a straight edge to connect the dots, draw a line. Okay? And then one last way that you might want to graph a line is identify the x and y intercepts and plot these 2 points and draw the line. That's something that some students don't use quite as much, and I'll give you a hint as to when it's a really good idea to do that is when the coefficients of x and y are easily divisible into the constant value, okay? So first we're just going to do one of those basics. We're going to graph the line through the point A, -2, 5. So let's plot the point -2, +5. Remember that that means on the x-axis you go 2 to the left and up to 5 right here. 1, 2, 3, 5, that's point A. And B has coordinates 3, -1. So from the origin, I'm going to count 3 units to the right and 1 unit down. So this is the point B. And then I would use a straight edge to connect those. And let's see if we can make it blue to draw that. Of course, it's off a little bit, so I can just use this tool to connect them. There we go. Okay, that's probably the most basic thing that you've been used to doing. When you first started graphing, you probably started with something like that. More often, as you get into higher levels, you'll use other forms more like slope-intercept. So let's look at a couple of other ways that we can do this. All right, we're going to graph these lines on the same coordinate plane just to save ourselves a little bit of time. So the first thing we're going to do is we're going to graph the line through point C, having coordinates 2, -2 with a slope of 1/3. So let's plot C. So starting at the origin, we're going to go 2 units to the right and 2 units down. Oh, I don't want that to move. So to get that to not move, we're just going to lock it down a little bit. There we go. And then we can do what we need to do. All right, 2 to the right and 2 down. So this should be the point C right here. Okay, and we have a slope of 1/3. So we're going to go from point C. We're going to rise 1, and we're going to run 1, 2, 3 units, and we're going to get another point. And you can plot more points if you want, so you can repeatedly go up 1 and over 1, 2, 3, get another point like so. If you want points to the left, then you have to go down 1 and back 1, 2, 3. What you're doing is you're going 1 unit in the negative direction, 1 unit down in the negative direction, and 3 units back to the left, also in the negative direction. And you know that a negative over a negative is a positive, so that's the way that you would get that. Again, we're going to draw that line using, we're going to make this one blue because that one's in blue again, so we'll put that line there and fix it a little bit, and then you're done. So again, this was just if you have a point and you have a slope, if you have one ordered pair and you have a slope, that you can plot the point and use the slope to rise and run. We're going to do that again. We're going to draw a line through the point D, -4, 0, with a slope of -4. We're going to do this one in green now. So we're going to plot -4, 0, which means we're going to go 4 units to the left on the x-axis. 1, 2, 3, 4. Whoops, we want green. 2, 3, 4. Here's 4. There's point D. And we have a slope of -4. So if you want to think about how do we think about rise over run when you only see one number, remember that if you turn this into a fraction, that would be -4 over 1. That's how you could write any integer as a fraction, which means we're going to rise 4, and I don't really mean that as a rise, but we're going to go 4 units vertically and 1 unit horizontally. Now we're going to go down 4 because of the negative. So we're going to go down 4 and 1 to the right. So from point D, we're going to go down 1, 2, 3, 4, and 1 unit to the right. We'll do that again. 1, 2, 3, 4, and 1 unit to the right. Again, if you want to get points to on the other side of point D to the left, then the negative sign can be applied either to the 4 or to the 1. We've been applying it to the 4. If you want to apply it to the 1, then you would have to go up 1, 2, 3, 4, and to the left 1, so that you're going in the negative direction corresponding to the x-axis, and up 1, 2, 3, 4, and to the left 1. So the negative sign does not apply to both it definitely does not apply to both the x and the y. It only applies to one or the other. If you apply it to both, then you've all of a sudden created a positive slope, right? All right, and I'm going to label these lines. So we're just going to call this is line A, and this is the one for line B. It's supposed to be a B, and then it looks a little bit like an F. So let's try again. Let's draw a line through point E, negative 4, 2 with no slope. We've got to remember what type of line that is. So E through negative 4, positive 2, we're going 4 units to the left. 1, 2, 3, 4, up 2 with no slope. So no slope means that's a what kind of line? Vertical line, right? So we don't really need to talk about plotting any other points. We just need to know that we want a vertical line, and that's it. So we're going to draw a vertical line through that point, and that would be the line for problem C. Okay? In general, I know I don't like for students to draw all kinds of lines on one graph, but since you're going to be mostly doing these online, you probably only have one per. So let's talk a little bit about slope-intercept form. Recall that slope-intercept form is y equals mx plus b, where m is the slope and b is the y-intercept. You usually see numbers in place of these. And then when you graph using slope-intercept form, you're going to plot the y-intercept first, right? So we're going to identify the y-intercept as this point. If we're going to graph the line y equals negative 3/4 x plus 5, the point that we're going to plot first is going to be 0, 5. And then we're going to use this slope right here we're going to go down 3. M equals, the slope is negative 3/4. So we're going to go down 3 and right 4 units, okay? After we plot our point, our y-intercept at 0, 5. So remember that the y-intercept is where it crosses the y-axis, so we're going to go from the origin, we're going to go up 1, 2, 3, 4, 5, plot the y-intercept, and then we're going to go down 3 and 4 to the right. 1, 2, 3, 1, 2, 3, 4, and then you're done. And you've got a point and a slope, and you can graph that. This is probably the most common way that students are accustomed to graphing lines. And I think it's a good idea whenever you graph them on paper to kind of write the equation of the line next to it. Y equals negative 3/4 x plus 5. So you know which line you were talking about, because we're going to graph another line on the same coordinate plane just to save ourselves some time a little bit. So we're going to graph 5x minus 2y equals 10 using intercepts, which is a little bit different. Using intercepts means I want to find out where does it cross, where does the line intersect the x-axis and the y-axis, each one, right? So if we're talking about intercepts, an x-intercept would have a y-coordinate of 0. So what we're going to do is, to find the x-intercept, we're going to substitute 0 in for y, and then we would solve. And again, just so you know, when is this a really good time? When you notice that 5 and 2 both divide evenly into that constant right there, the coefficients of x and y divide evenly into the constant, which makes it really easy to graph it using intercepts. That's probably the time that I'm most likely to use that. And then that makes this whole entire term kind of go away, and we get 5x equals 10, x equals 2, and that's the ordered pair to 0. That's an x-intercept. Now let's do the y-intercept. You can either put it in slope-intercept form if you really want to, but it's much easier to recall that essentially what's happening here is that if I want a y-intercept, that means every y-intercept has an x-coordinate of 0. So 5 times 0 minus excuse me, minus 2y equals 10. So this term kind of goes away. Negative 2y equals 10. Y equals negative 5. And then that's the order of pair 0, negative 5. So what we're going to do is we're going to plot those 2 points and then graph it. So we have 0, negative 5, and 2, 0. So 0, 1, 2, 3, 4, 5. 0, negative 5, and 2, 0. Makes it a lot easier to graph that line. And here is the... Oh, I did not get the line tool. Whoops. That's no bueno. So let's fix that real quick. Wanted to get a nice line and definitely messed that up. Alright, let's try that one more time. We've got line, arrows. Here we go. That's better. Okay, and that would be the line 5x minus 2y equals 10. And you're done. Okay? That's the end of that one. That's it. That's all we've got for today.